So I'll try to keep my session short and then answer questions, as many questions, and try to make this interactive. The key goal for this session is to talk about, AppViewX and how AppViewX architecture is aligned for energy and utilities specific deployments, right? And what can we do there? And how can we rethink or rather, in the aspect now that there is a lot more focus with all the recent incidents that have happened, there is a renewed focus with securing endpoints, securing the networks and whatnot, especially in the energy and utilities area. So we look at how we can redefine or reimagine for the utilities segment. And more importantly, let's look at the traditional approach, the normal deployments that has been there as an option for typical enterprise. Now, typically there was like a centralized deployment model. So we will look at how AppViewX sort of changes that a little bit, where you have sort of a hybrid model, right? Where there is a central control, but at the same time you have that segmented approach as well, right? Then we would look at specifically for energy and utilities, what is the difference and how we can especially in the OT environment and segmented environments, how we can take this approach and achieve that as well. So we're gonna look at that. Okay, so the first use case is when we talk about auto enrollment, when we talk about certificate management, right? There is two ways to enroll a certificate, right? One is it's a pull model where the end device is smart enough to understand a standard protocol and it basically communicates and then gets a certificate, right? The other one is a push model, right? So typically in the traditional approach, what we usually have done is there is sort of a central system, right, which has a database there associated, and this database has all the certificates, and you basically connect to those individual systems. And again, there needs to be a firewall port opened for all of those to communicate to the central system. And either you have a proprietary protocol, right, which is not the standard enrollment protocols, where the system has the knowledge of the end device and uses it to communicate using an API. So that's a push model. Then there is a pull model where the end device communicates to the system using SCEP or the standard protocols, EST, SCEP, ACME, and whatnot, right? So in all of this, you have to be able to talk to the central system, especially in a segmented environment, right? When I say segmented, this could be the OT environment, where this could be the gas, and this could be the coal or water and that type of segregation, or it could be a network segregation as well, depending on however you implement it in your organization, right? What AppViewX enables is with the cloud connector is you have the cloud connector, which basically talks to the central common rail, right? Where you can have the AppViewX running. So this common rail could be your internal common network, or it could be a cloud rail as well, depending on how you want to plan the deployments. You have a central inventory, central reporting. You could even have multiple LDAP services, each isolated, and this could be a segmented, or rather a separate acquisition that has been done, which basically is currently not integrated into your central platform, or you're planning to keep that separate more from a generation to distribution, and you want to segregate those, right? Depending on how the business use case are, you would basically have those set up independently. And with the auto enrollment capability, right, it would basically talk to the cloud connector, get the certificate from the cloud connector in a secure standards based approach, right? The cloud connector will talk to AppViewX. All of this is mutual SSL, all the security controls, enhancement, everything set up in place. And AppViewX would be the RA, which is talking to either your external PKI or your internal PKI and getting the certificates issued to the endpoints. Now, the key benefit of this is that you don't have to have multiple instances of AppViewX running. Now, that is always an option. That's more of a traditional approach where you would have a separate instance running in each of those environments, right? So that's definitely an option. It gives you a complete isolation, complete access separation, and whatnot. That's available. But then if there is a need where you are looking to consolidate, or if you're looking to have a common rail of common services and then keep the segments separate, you have that option of achieving that as well, right? Now, in this particular aspect, right, you have the option of using PKI or the issuer separate, right? So I keep talking. I mean, I use this analogy of currency, right? So when the PKI minter or the certificate creator, right, which is issuing CA, they are like the minting currency, the mint that basically prints currency. It has ways that it cannot be counterfeited at security capabilities and non-repudiation. A whole bunch of other capabilities are there to verify and to make sure that it is minting the right certificate or minting the right currencies. Now, but the currencies don't get distributed directly to the users, right? Directly from the mint. You cannot go walk to the Federal Reserve and ask for a $20 bill, right? For you to use or a change or something. You go through the retail banks. Now, the retail banks are the only ones which can communicate to the Federal Reserve to get the currency that's needed. The retail banks have a detailed audit, detailed accountability. They even have automatic teller machines, which basically distribute the currency automatically. Now, the way I look at AppViewX is like those retail banks, which has a detailed auditing, reporting capability, detailed inventory, and all the security access controls needed to securely issue certificate, either through the automatic teller machines, in this case where it's a fully automated enrollment process, or through manual establishments where you can get a manual request using the web-based URL and whatnot, right? So the key benefit is that your PKI environment is completely isolated and secured. And like what Jeff was mentioning, right, you have a complete agility in terms of what PKI layer you use. You can decide to change that in case if there is a compromise or if there is an expiry, whatever that is, right? Or maybe tomorrow you might need a more short-lived certificate, right? So once you basically have all this fully automated, right, there is no need for 1-year certificates, right? You can even change the currency overnight because everything is automated. So there is no need for you to keep that particular currency long term, right? So it also enables for a short-lived, reduces the attack surface, increases security because you're able to be agile and have the flexibility to roll things over as needed. So this is the first use case about auto enrollment, end-to-end auto enrollment in segmented environment. So the next use case is what I believe Richard and Jeff did highlight about the RDP, the Windows RDP, right? So Windows RDP store, where when you are remote connecting to those segments, and you want to basically handle the RDP certificates on those endpoints, you can easily enable our EST client, which basically fully automates through a standard-based protocol, and the cloud connector acts as the EST server, right? And it basically issues the certificate to all the endpoints that is needed, right? And all of that gets centrally inventoried, reported, and whatnot. That way, when the end user is connecting, whether it's common rail or from a segmented rail, right, into those Windows store, the whole process of the certificate management is handled and automated. It sort of enables you to simplify the whole process, and basically handles that in a lot seamless way. Right now, the reason I'm taking this, I mean, this applies for a whole bunch of use cases, right? The reason I'm taking this RDP use case is because this is one of the interesting pain points, especially when it comes to multiple segmented environments. Now, you might want to enforce security as well, right? Where segment one doesn't connect to segment two, and a whole bunch of other enhancements that we could add. Everything on the right hand side remains the same. You can decide to change basically this piece of it. It's completely abstracted. Oops, sorry. Nobody has to know on the right hand side. And on the left hand side, the use cases change depending on what you're using, right? It could be a standards-based use case. It could be a push model as well. We'll look at that also. Now, the next important use case is about discovery or visibility, right? Now, this is another important aspect, especially when you're talking about segmented environment. See, I keep talking about segmented environment, right? See, since there has been an awareness about how to secure or enhance security, right? There has been talks about zero trust models, zero trust deployment model, right? Zero trust application deployment model. In all of those, what it means is you will have to segment your network. Now, whether you use micro segmentation, meaning for every application it is segmented and you cannot talk to each other, right? It's a full zero trust environment. We have deployed that in certain financial institutions, certain banks, where they have completely implemented a zero trust network. Nothing can talk to each other, without verification, without validation, and a whole bunch of other stuff. Now, when you look at zero trust environment, when you look at containerized deployments, that is well suited for zero trust east-west traffic. Now, what does zero trust mean, right? Zero trust doesn't mean that you put a firewall in between, segment 1 and 2, right? And then it basically talks to the firewall. So then, in essence, what you would be doing is you would be punching so many holes in the firewall that you might as well, remove the firewall, right? There is no protection in that aspect. Zero trust is about every connection is authenticated and verified before it connects to the other service that is there on the other network. Now, if you look at a service mesh, the best approach to it would be an Istio service mesh, which basically verifies. It actually has a sidecar which implements that mutual authentication, handles the services across, and then does that across the deployment, right? Now, in that scenario, since AppViewX is has under the hood uses Kubernetes and containerized with Istio and all that, you can implement that in a completely zero trust segmented environment. Now, when we talk about zero trust with these multiple segmentation, it becomes challenging to discover those networks. Now, there are two ways, again, like what Richard mentioned and also Jeff highlighted about it, right? Where either you can have AppViewX do the scans. We have all the capabilities needed, and we have implemented that quite a bit into the monitoring rails. If you have separate monitoring rails where it can sit and then look at all the endpoints and discover, or it can integrate with your existing scanners, whether it is QualiScan, Nessus, Rapid7, whatever you're using there. AppViewX has integration with it where it can basically go pull the data and assimilate the data, rather absorb the data and use that for enrollment. Now, from a discovery perspective, it gives the visibility. From the enrollment perspective, it provides the automation. Now, this enrollment could be through a standard-based protocol or even through a plugin or an API-based capability, which is a push model, right? There is a pull model and a push model. In the push model, now you don't have to talk to every device on the network. Some devices would pull the certificates based on standard-based protocol. The others, you can push it to those end devices. That depends on the type of device, depends on what the capabilities of the device, and that discovery enables you to distinguish between those. And that discovery is done by your existing tool. So we take that data and use that to take the decision whether you want to communicate to that end device or not, right? And then irrespective of how you do that, with the discovery, you have that central reporting and you're able to get the details reported and central inventoried and all that. And in every aspect, like during a push or an auto enrollment, you can have additional approval request, which the PKI operator is able to handle and manage the whole process through. And this is done for both internal and external certificate authorities as well. So it makes it a lot seamless in that. Now, let me summarize this, right? With this, I'll stop and I'll answer any questions. Please do type in your questions that you might have so that we can look at it a little bit more in detail. Now, when we look at the IT side of things, right? Now, it could be leveraging the cloud environment where you might be running PKI in AppViewX's cloud as PKI as a service. AppViewX in the cloud where you're running AppViewX as a service or consuming it as a service, where you could leverage AppViewX's CA behind the scenes, right? Or it could be third-party CA through AppViewX behind the scenes as well, irrespective. We are vendor neutral in that aspect, right? Depending on whatever vendor you want, we would offer that as a service for you to consume, right? And it basically integrates with your customer environment, and then it handles that and automates it. And when we look at that a little bit in detail, you could have the CA in the cloud, which is, any interest, whatever that you might use, right, could be in the cloud. And AppViewX could be running on your customer environment. Now, this enables you to keep, AppViewX also has the capability to do an escrow, key escrow, right, centrally. So with HSM backing, a whole bunch of stuff. Now, you keep control of the keys, have the escrow, and then communicate to a cloud PKI to issue certificates, right? It could be Google CA, right? Or it could be Amazon private CA or Entrust CA, whatever you're using, right? It can communicate to that, get those certificates, and automate that in your on-prem model. The third approach would be AppViewX could be running on the marketplace, right? Where AppViewX can be in any of your cloud or as a service from the marketplace on any of those clouds. And you communicate with the CA that also is in the cloud, or it could be from third party, and offer that. All this is an IT side of automation, right? You'd have already implemented, familiarized with it, and all that. So you have all those flexible options. Similarly, on the OT side, where you could have AppViewX sitting on the common network, on the common rail in your network, and could have separate segmented access to whatever internal environments that you might have, internal distribution networks that you might have, right? Where you want to isolate them, but at the same time manage them centrally, right? Or you can even have them under those isolated networks, but then have the common rail communicate to the CA. So you have a central CA, but then you have a distributed deployment network. Oh, sorry. You have the distributed deployment network for each of those individual environments, right? You have that flexibility and option as well, right? And in all of this, right, if you want to have AppViewX to handle the CA side of things or the issuing side of things, it can handle that as well as needed, depending on what your requirements are. I think with that, I'll pause there and I'll answer any questions that would have come up.
Hey, Murali, we've got a couple questions here. The first one is, can you provide some insight on how to secure field area networks?
Yes, so it's an important question. I think we can talk quite a bit about the field area networks, and we've been talking about that yesterday about how we can secure the endpoints or IoTs, especially in a field area mesh, right? In the mesh network, what can we do to secure that? And what can we do to automate and implement or secure the edge, right? Whether it is a Cisco FAN implementation where we basically automate the issuance and track that issuance across end to end. So there are quite a few capabilities that we can, use cases that we can talk about. Maybe we could set up a separate time to walk you through what all we provide. But the key aspect here is there are, again, three types of devices when we talk about IoT, right? The full OS device, right, which is just a smart device, which can handle certain level of auto enrollment or certain level of communication, right? This could be the IP phones or the printers to that aspect, right? Or which runs Windows Windows OS, the IoT OS, and Linux, VXOS, and those type of devices, which are smart, which has certain processing power to handle, right? There is a different way of handling that. Then there is this standard firmwares, right? Or single board computers like ESP32 or some of the standard devices, which has an inbuilt flash firmware. It has a Wi-Fi connectivity, has ways to communicate and all that, but then there is limited capabilities for management, right? And third one is just a sensor, an actuator, or whatever, right? It has very little power, but then communicates more from a peer-to-peer mesh perspective. There are different ways to approach each one of those, and different ways to manage with the central controller and whatnot. So we have quite a bit of use cases depending on how that is implemented and depending on where it is implemented as well, whether it is an enterprise IoT, right, EIoT or IIoT, if it's an industrial IoT. The use cases differ there also.
Great, thank you. The next question is, does AppViewX have a solution to work with DNP3, secure authentication, used in energy and utility SCADA systems, OT environment?
I need to check on this. I don't think we have rather, I'm not aware of this. Will I get back to you on these details?
Okay, great. And the last question is, how does AppViewX PKI connect with each segment? What is it called?
Okay, so there is something called a Cloud Connect. So the Cloud Connect is sort of the aggregator where all the requests would come to the Cloud Connect, and the Cloud Connect has a mutual auth to the central mothership, and that would basically communicate and provide all the services there. So it sort of acts as a full proxy or an RA capability sitting there in that particular segment. And you could have, it's a lightweight system. It's a stateless, lightweight system which sits there, and then you can have multiple instances running if you want high availability and whatnot.